Tankers take particular skill to drive. They also take particular skill to operate safely. Pressurised discharge is quite often used to unload tankers. It's a convenient method of discharge, but it's not without danger. Liquid tankers generally use about 30 pounds per square inch of pressure to offload. This leads to a very dangerous amount of pressure inside the tank. Quite often manufacturers will fit safe bolts to man lids. These should prevent the driver from being able to open the lid if there's pressure left inside the tank. To carry out pressurised discharge, a site-based, or more commonly, a vehicle-based compressor is connected to the tank. The air inlet pipe is opened and compressed air builds up pressure above the liquid inside the tank. Most modern tankers can perform this operation from the ground level. Drivers will be aware the tank's emptied by a reaction in the delivery hose and a reduction of pressure inside the tank. Once emptied, it's vitally important to ensure that decompression takes place. Pressurised tankers will be equipped with an air release line. When opened, a large amount of pressure instantly escapes from the tank. Failing to decompress the tank can have fatal consequences. Another danger of tank vehicles is a BLEVE. A boiling liquid expanding vapour explosion is more powerful than most other explosions. Pressurised flammable vapours with enough power to burst the tank open can result in huge fireballs and throw the tank hundreds of metres. When tankers are loaded, ullage is left in the space above the liquid. This allows for expansion of the liquid in normal conditions. If the tank is involved in a fire, this will cause more heat in the liquid and create more pressure as it rises into the ullage space. As a safety device to prevent the tanker from bursting open, the pressure relief valve will open, venting pressure. As the vent valve opens, the liquid level inside the tank begins to drop. Even with the flames acting on the outside of the tank, provided there's liquid on the inside of the tank, the metal won't become sufficiently weak to fail. Once the heat starts acting on the vapour space above the liquid, however, the metal, not being cooled by the liquid on the inside, will become dangerously weak. The pressure created by the rising liquid level inside the tank will then be sufficient to break through the weakened metal. When this happens, the compressed flammable vapours will instantly escape from the tank and meet the flames on the outside of the tank. This will result in a very powerful explosion.